Hello and welcome back. So far we have understood how the decision tree splits the data and constructs the tree, and then using the tree how the prediction is made and what is the overfitting problem with the decision trees. And we have understood all these things using Gini index, the impurity measure Gini index. Let us try to understand what is information gain. Information gain is nothing but cross entropy formula. It uses cross entropy formula to calculate impurity. So you can see, we have taken one example and tried to calculate, and you can look at it later also. So there is a problem, we would like to address a problem with Gini index and information gain, and there is a solution also for that. So Gini index or information gain has a problem of favoring the columns which have got more distinct categories. In this example, if we have taken the day also as an input column, it would have favored day as the first column to split. In this day column we have 14 categories: outlook 3, temperature 3, humidity 2, wind 2. But day column has got 14 categories, so it would have favored, the Gini index would have favored, or information gain would have favored the day column, or it would have given zero impurity to day column, and the algorithm would have splitted the data in day column and it would have completely overfitted. That's a problem. So the problem is called as bias towards multi-valued attributes. If you have more values, more distinct values in a particular attribute, the algorithms are biased towards it, the Gini index and information gain both. So if you look at the Gini index example here, if we have taken the day column as the input column, it would have calculated zero probability for day column, because if you look at this formula, probability of day 1 is 1 by 14, because day 1 only once it occurred out of 14 records, and probability of S given day 1, on a given day either people may play or not play, right? So it's going to be either yes or no. If you get a probability S given day 1 0, probability of no given day 1 is equal to 1. Like that for all the days, any day either they'll play or not play, right? So you will get zero probability, right? So 0 by 1 and 1 by 1. So on that day, right, the only one record is there for day 1, and yes or no only 1, right? So it's going to be 0 by, all terms will become 0, so totally it will become 0. When it becomes 0, and if the algorithm chose day as the column to split, the first split, right, best feature is day, and if it made day column as the first split on the data set, right, it would have been like this: day 1, day 2, and so on, and day 14, right, day 3, like that, right? So every node would have been with one record only, right, one record only, like that. But day 15, when day 15 or day 16 comes in, you will not be able to predict, because there is no day 16 in the data set, and you cannot traverse through the tree, and you cannot predict. On our train set it will give 100% accuracy. On any other record it will give 0% accuracy. So that is the problem with Gini index and information gain. If you have a column which has got more categories, the Gini index and information gain will make the first split on that particular column. To avoid this, there is a concept called gain ratio. So it uses information gain formula and calculates a split info, a penalizing number or a normalizing number for the information gain. This number is going to be high for the columns which have got more categories, will be low for the columns which will be like with less number of columns, kind of thing, right? It's a high level view I am giving. When you calculate gain ratio for the day column, it will always give you a low number, and for the other columns which are important, it will give a high number. Unlike the Gini index and information gain, we will take the highest scored gain ratio column as the best column. In scikit-learn I haven't seen the implementation for gain ratio, but R language has got the implementation. In C 4.5 and 5 we have implementation for these. So that is about the different algorithms and how the algorithms work, and disadvantages, overfitting, and the how the columns will be chosen. If you look at the comparison of three different feature selection approaches, right? The Gini index, information gain, and gain ratio. Gini index is biased towards multi-valued attributes. We have seen that the day column has difficulty when large number of classes present in the target variable. Calculations are going to be too high. Tends to favor tests that result in equal sized partitions. That means when it tries to split, right, it will try to split the data into equal number of partitions. Sometimes it may not be right, sometimes it may be right. And information gain biased towards multi-valued attributes. Gain ratio tends to prefer unbalanced split in which one partition is much smaller than other. That's a disadvantage. Sometimes this is good, sometimes that is good. So that's it. That is about the decision trees and how actually they actually choose the best features and make the split. In coming session we will understand overfitting and underfitting and pruning of the trees. Thank you.